Today's musing is about an interesting take on Johari Window on analyzing, taking a view from Johari Window as to why bugs emerge, why bugs slip, and what we can do about it. And what can be learned and how can be better. That is the idea here. So, when we ask a simple question, why do bugs emerge in the first place in this stage of construction, and why do they slip when we do a validation? I'm sure all of us have great reasons and we probably understand it pretty deeply. We all know that the bugs are not just about what is stuff that's written in the code. It's more often something that starts earlier. It's all about how they take root in the thinking, how we think, how we perceive, how we understand, and so on. Bugs are really mirrors which reflect how we think, how we speak, how we rush, and so on and so forth. Of course, some bugs bloom in silence, and some slip when we're looking elsewhere, and it's a nice way of putting it. But if you kind of detail it out a little bit, I'm sure there are many more reasons. There could be something like this: assuming too quickly, not questioning enough, or questioning and asking and finding information very later. When there is ambiguity, maybe we didn't clarify, so we kind of continue on with certain amount of ambiguity. And sometimes, simply because of the fact that we are troubled for time, we trade understanding for urgency. So these could be some of the key reasons as to why bugs happen in the construction phase, which manifests in the code, but really they take root in the thinking. Now if you go to the next question and ask, why do bugs slip? Fine, it happens in the construction, we validate, it also slips, and I'm sure we've got very good reasons too. It happens because probably it's not necessarily only from neglect, but sometimes we don't challenge it well enough. We trust too much. We probably forget sometimes that the silent churn. So more often, that could mean that we test what we expect, sometimes missing the surprises, maybe testing certain happy or clean parts, maybe not all the unhappy or the jagged or the crooked or the other alternate parts. I'm not saying we don't do it. These are some reasons why they happen. So surprises, parts. Sometimes we more often echo, because we kind of relate to the tools. It runs, maybe regression. And sometimes in the entire process, blind spots stay untouched. So, I'm sure we can expand this a little more, but you get the gist, you get the drift. We're just trying to put in a context of why they happen and why they may slip. And then apply an interesting tool of Johari, which is more often a tool from the psychological piece, and see what we can learn by application of such a tool. Now, the Johari window, which is basically more of an analytic approach to what I know and what others know. So if I put in, so to speak, the x-axis about the self, about me, what I know and what I don't know, and if I put the y-axis, what others know and what others don't know. So that means if there is a piece of information, the x-axis indicates I know it or I don't know it. The y-axis indicates others know it or others don't know it. So if you put these 2 by 2, we get a 4-quadrant picture, and this is called the Johari window. And therefore, if you look at the quadrant on the rightmost top, it's the leftmost top, it is what is known to me and what is known to others. That's how you read it, known, known. And the second one would be known to others but unknown to me. That means other people know, I don't know. And I'm sure you can understand the rest of the 2 quadrants, which is the bottom. And how do you read it? If you want to expand upon it and see how this looks like, this is how it's probably going to look. This, if I can give a name to it, the leftmost quadrant on top, it's like the open area where all of us know, both of us are aware, me and the others. Whereas the rightmost quadrant at the bottom is they also don't know, I also don't know. That's more often the unknown. And the other two diagonals, that is on the top right and the bottom left, which is like a blind spot. I don't know, but others know. It's like saying, I don't know that I'm getting angry, but others perceive that I'm getting angry, right? And that's the way I can analyze. And therefore, the first thing that I need to know is, if I want to control my anger and be a little more patient and nicer, then first is for me to know. So I need to move from this spot of not known to known, and that's how improvements and changes occur. I guess you understand the drift, right? If it's known to me, it's not known to others. It's a hidden area or a facade, right? So keeping this idea of known to unknown as these four quadrants, which is symbolized as open area, hidden area, blind spot, and unknown, we're trying to understand some of these causes of why bugs emerge and slip in the phases of construction and validation, and put them into these areas and ask ourselves, how can I get better? How can I improve? That is the gist. Okay? So we are trying to look at the issues that happen, some that happen in the earlier stage, some that slips out and goes out and happens in the customer stage. We're looking at it not through the sense of, we are looking at it not through awareness, we're looking through awareness, not tools or checklists. So what we know, we know. What we know, we don't. What others know, but we miss. What no one sees until it breaks. That's the whole idea here, right? So the next few slides, which display contents, kind of tries to put this idea together into these two phases. And if I want to explain upon, this is how I'm going to look at it from, if I take a Johari window view in the phase of construction as to why bugs emerge, these could be some of the ideas that we could probably think of. Why does it happen? Well, sometimes we have communication issues and business logic is not well written or understood or clarified. We differ, and therefore bugs happen. So obviously we can do something about it because we know that we could improve the communication. Or sometimes we know there is an impact because it is complex and we don't know it fully. We probably suspect initially, we can analyze, and therefore it might slip. So we know that we probably have to analyze a little more deeply, understand the complexity, figure out the risk, and do what we can do to probably prevent some of those or figure it out at the early stage. Let's take the other way. I'm not going to go through each one of them. I think you get a drift. So like that, if you look at the known unknowns, what is known but I don't know. I am over assuming, I am under questioning, right? And therefore it's not known to me, but other people see it. So I have to now do something about it, right? Unknown knowns. There is tribal knowledge that is there with others. I don't know that. Certain specific nuances which other people know or somebody knows, I don't know. And therefore, we need to do something about it. Maybe it's siloed information, maybe we need to share, maybe we need to document, maybe we need to put it in some kind of a knowledge system and stuff like that. The unknown knowns are the most dangerous ones because neither do I know, neither do other people know, right? For example, it could be we don't understand the fact that our mental models and the behavior are disjoint, and therefore there is a notion of emergence of new issues. So what you see in the bracket is like a bit of a categorization, communication related, complexity, category or related and stuff like that. Timing traps, concurrency, which is a fairly complex issue, and transactional system, race conditions, synchronizations, things that are fairly difficult to figure out because it's a very serious unknown, as timing adds a completely different dimension, and therefore one has to be much more careful because however hard you try, you still have a possibility of missing. So what we're trying to kind of look at it and say, hey, here are some of the causes as to why bugs emerge during the phase of construction under some of these categories of thinking, communication, process and practice, complexity and so on. And as we go to the end of this, I will probably show you a more detailed table to give you a little more better perspective. If If I apply the same thinking to the next phase of validation and ask why would it slip? Because maybe it is as simple as we are running checks, not really running tests. We are following the rules. We are not trying to break the rule. And therefore we are very process conscious and not probably wanting to go a bit of an out of the box. I guess we understand that and we do work very hard to take care. This is one possible reason. The unknown, if I go to the extreme version, it looks like I don't see that as a bug. I think it's just noise. I mistake it. And therefore it gets lost in probably the noise. And sometimes failure, they need a big story to reveal. You don't know why it happened. It's like the AI 171 crash. People are still trying to figure out, right? It needs a big story for you to figure out what happened. Why did it crash 39 seconds after it took off? It's a fairly serious unknown. Hopefully, we will figure it out. The team will figure it out. In the same fashion, this was all the slips, right? Remember, it was tested. The pilot is, the aircraft is airworthy. Pilots are deemed fit. Equipment has been validated, and etc., etc. But then, unfortunately, it was a fatal crash. So that's one example of an extreme version. If we look at the Johari window validation phase in the first column, known unknowns and known, it's like saying, we test what we understand, skip what we don't. Bit of a knowledge issue, so you have to be aware and continue. The unknown unknowns, again, notions of assumptions, gaps in experiences. So if I'm more mature in experience, maybe I'm a little more wary of assuming. The forgetting of past experiences, which is about history. Right? So these are some ideas. So I'm not saying this is the only comprehensive list of all the categories, nor all the types of broader issues. The intent was to kind of muse about how would it look if I apply a Johari window view so that I know what I know, I can figure out and try to find out what I might not know, and therefore try to move into the quadrant. Each of these moves from unknowns to knowns and then ultimately a known, so that we all become more mature in how we do things earlier and later. Right? And that was the idea of these slide and these two slides. Now I have to kind of come and talk about and look at it and say, if I adopt some practice, in this case, since I am closely associated with HyBIST as a personal scientific practice of probing, smart probing, I'm trying to find out if I adopt whatever good, meaningful practices, and practices are highly individualistic, they are hopefully based on some kind of methodology, which means there is a bit of a science to the background. How can it help in this Johari window? How can it help in the act of the earlier stage of construction and the later stage? Right? That's what I want to put. And ultimately, I will map it to the Johari window and say, hey, here is how methodologies help. And subsequently, I will also ask, in the current world of AI, how does AI or how can AI assist? And I again map it back to the Johari window again. So I'm trying to put the story together by by setting up the notion of emergence, slippage, at construction, at validation, using the methodology as a basis to say what can I do, and then finally taking the assistance of AI after applying the method and asking where could this AI assist in this methodology. That's the whole musing all about. Now in the context of HyBIST, which is more of a methodology which expands into hypothesis-based immersive session testing, where the intent is to exercise a meaningful left brain approach to probe deeply, broadly, and also apply a right brain approach to probe creatively. And therefore, it is more like provoking insight. It is not about the act of execution alone. It's not about just testing as viewed as an act of doing. It is about an act of provoking insight. That is what truly the methodology stands for. So, what it allows us to do in the construction phase, which I will elaborate a couple of slides later, is it helps us reveal what rules may be implicit and therefore surface some of those implicit rules, making it more explicit, and therefore understand behaviors better, figure out certain interesting cases which are extreme corners, surface some assumptions or help spot assumptions. It tries to help you to figure out what can break, not what should work. So it means it's a bit of a fault-oriented model, a fault-oriented approach, rather in addition to the notion of a conformist compliant approach. So the idea here is any methodology, in this case since I am closely associated with HyBIST, a methodology should illuminate so that during the construction phase, some of those categories of issues that we broadly talked about should hopefully fade away. In a similar manner, if I look at how does it help me, how does it illuminate in the context of validation. I'm using the word illumination here just to highlight the fact it's not going to solve by itself. It provides you the ability to see it. And therefore, in the context of validation, HyBIST as a methodology encourages us. Encourages to what? To think from a failure angle. Not look at it only from the doing angle. When I say doing angle, whenever we are given something to test, we probably get into an act of doing. Of course, we understand. We try to figure out potential conditions, scenarios, faults, etc. So there is a notion of a forward approach of coming up with some test ideas, test scenarios, coming up with data, executing it in whatever form or fashion, figuring out a larger plan. Bit of a forward approach. The backward approach could be possibly what could be failures, what could be potential issues, and therefore force you to think from a hypothesis-based approach of what could go wrong, and therefore try to marry the backward to the forward approach. And we are not looking at just outputs, we are also trying to figure out how it illuminates this is to help you trace some potential assumptions that people make, and therefore, because you're asking a lot more why questions, because it's more of a probing methodology. Right? And because we are applying a probing mentality here, and we're trying to come up with smarter probes, and they perform the act of probe more smartly. That's why the left and the right brain kind of fuse. What we're trying to do is we're trying to see, well, we are able to spot those things which don't really announce itself, which are not very visible. And that's the idea of HyBIST. So I'm just trying to give you a very large high-level picture of how methodologies can play a significant role in possibly the emergence and the slippage in both the phases, right? Now, in the current world, everybody is enamored with AI. We seem to have a new kid in the block, and we are all excited. But where does it fit? Certainly, AI, we all know, is not a replacement, but then it's more easy said than practiced. But certainly, it's a revealer. It is a brilliant aid to help us possibly reveal, to help us surface patterns of issues. Right now I've been working with an organization where we've had some interesting issues that have been found, and I've been taking a look at some of these issues and taking a recourse to AI to figure out certain patterns of issues that have been found later, earlier. I've qualified it into quality levels of HyBIST and so on and so forth. The idea is to kind of get some idea pattern so that I can move it into the known and therefore make it more common to all of us, and therefore do a much better job. Right? So surfacing patterns that we ignore, constantly stress that maybe we are making an assumption and therefore lest we forget. So the AI, in whatever form that we do, more often generative AI I would assume, is about a mechanism by which we can try to find out by asking questions, by figuring out the stuff, because we just treat it as a nice assistant. And certainly it's something that allows us to get a second glance at sometimes what may be deemed as obvious. And therefore, I guess, there is a fair amount of use that people put it to by using it as co-pilot, as part of the early stage, and so on and so forth. And if I ask, how does it fit in the context of validation? In a way, very cutely put, it's more like saying, hey, maybe AI listens to what we miss. I'm not trying to say AI is better than you or me. I'm just saying that it is probably more clued in, and therefore it's able to mine a lot more interesting stuff, which sometimes is a little feeble to us normally. So therefore it helps us amplify some of those things that we could possibly miss. Why? Because it spots recurrence, it spots anomaly, it fills the space between scrutiny and speed, meaning it helps us to scrutinize far more, deeper, broader at a much higher speed in some cases, right? And therefore it helps us to amplify our process of discovery. And since we are in a conversational mode with it in terms of finding out certain answers, asking questions, asking ideas, doing something aided by that, it's the whole thing, it turns out to be much more of a thoughtful curiosity, because it helps us guide a little more. But I must confess that I am trying to view it more of a more serious assistant, in addition to doing certain jobs by itself, right? So having kind of set the context of the emergence, slippage, Johari window, how a methodology like HyBIST could help, where AI could possibly fit in, let me just jump into a more detailed version. I'm sure the intent is not to walk through each of these lines, but I just want to read out and highlight maybe one or two of these, which I will do in a second. What this picture kind of illustrates is a simple table, which seems very dense, so don't attempt reading all the lines right now, but let me just give the context. As you can see, it's got 4 sets of gray boxes. The first gray box is known, unknown, unknown, and the last gray box is the unknown, unknown. The first column seems to indicate the cause of why it emerges, because we're talking about a construction phase. The second and third column kind of highlights how can HyBIST help and how can AI assist. Now there are certain legend out there, ABC and star and the up arrow, which is there in the cause and so basically I've said incomplete thought bracket A means maybe incomplete thought is categorized under the thinking. If I look at rigid process, which is third row in the cause section, it is under B, which is process and practice. Like that you might want to read. When you look at the AI assist, when you say arrow, up arrow, suggests mining missing flows, the first one, third column, it simply means AI is an assistant. Whereas when you say star, maybe AI can do the job a little more completely. That's the legend. So let me take a couple of them to illustrate what I mean. So now maybe let's say there is a cause. Because of time pressure, I miss a few things. So what can I do? How can methodology help? How can AI assist? An easy thing to illustrate, right? Maybe I use light probes for fast feedback. So I'm looking at it from how can I generate deeper probes, surface probes, faster probes, better probes, and so on. And therefore, how do I look at it from a coverage? And that's where methodology forces us to think of it as certain meaningful probes. We generate certain fast drafts of probes, maybe convert that into automated suites as appropriate. Maybe some of those automated suites can be generated more often in full rather than be assisted, and therefore that could be how an AI could assist. On the other hand, let's say the unknown unknown, which I've highlighted, which is the emergent behavior. So that means something emerges out of a new one, and therefore we're trying to figure out what can I expect, and therefore how can I come up with probes which are driven by expectations or outcomes to find potential side effects that emerge. So I'm kind of using the methodology from a hypothesis perspective to come up with certain probes, but look at it from outcome and expectation and so on, and build certain interesting probes. And to do this, maybe AI can assist me in maybe simulating certain patterns, but I can ask it to say what could go wrong here, what could be certain pattern that could happen here, and I can therefore get a little more better information. But it must be understood that it is an assistant. It cannot give you an answer. So the intention of this particular table is to kind of correlate the potential cause to how a methodology could be of assistance, and where an AI-based stuff, along with all other tools that we use, could be of some view. Again, as I always put the disclaimer, this may not be understood as a complete table that is total. In a similar phase, the mapping of Johari to the methodology of HyBIST to the AI in the validation phase, and I've tried to highlight some of them. I think one of the easy ones that we can understand is the top first box, which is the insufficient coverage. So you're trying to say, can I map to a code? Can I map to code path? And it could be code path as in terms of a structural piece, which is more often common. And you can also take it to the functional piece and so on. So that's obviously, sometimes AI can easily help in addition to all other tools that we know. If I go to the unknown, there are some new emergent issues that come as field. So what are we trying is how can I harvest some of these edge cases? And that's where I'm looking at learning patterns. So can I use AI to analyze categories of issues, figure out certain patterns of issue making, and therefore use that to help me figure out from maybe certain field issues, certain issues that have been found late, and therefore use it to harvest some of these logs of users to come up with interesting probes that I can apply as we go forward. Because remember, there's an unknown, which means it has missed, and I'm kind of seeking and I'm using hopefully a better intelligent technology to do this job. So like that, we can look at the other aspects too. So to conclude, so to speak, bugs don't just happen. They quietly whisper. They don't just slip. They kind of warn. The question is, are we listening? Right? And that's what we're trying to understand. How can I heighten my sensitivity? How can I, probe much more better? And therefore, what we've tried to do is to use one of the ideas, use Johari as an interesting tool to help us to look within, and then a methodology HyBIST to help us and teach us to look deeper. And finally, of course, the AI today to listen wider. And therefore, I think when we want to build, we must see well. To validate wisely, we must wonder often. And to me, ultimately testing, like all of us probably understand, the act of validation, the act of testing, etc., is about questioning. It is about probing, in addition to executing those probes, which is humanly or machine-wise. But the central theme of the entire notion of good quality is always about clarity. Because all we're trying to do is to simplify things, to see well, and if I'm able to have a good mental clarity, be it a developer who's constructing or a person who's validating, the ability to see matters. And therefore, to be able to see, we might need some methodologies, need to be aware of our own practices internally, look inward a little bit, and finally, of course, have this permanent sense of curiosity, which allows us to wonder and which allows us to do a better job. That is what I wanted to share with you, but the focus kind of came in from an interesting idea of the Johari window applied to our context. I hope it was of some interest. I hope it was a slightly different way of looking at things. Thank you so much for patiently listening to me today. As always, I've tried to put a slide of what we do as a company. There are a variety of different things that we offer as solutions. Some of them are tools, some of them are coaching mechanisms, which either as classes or either as consulting. So what we as a company have been primarily trying to do is to look at it from, enabling people to discover smart QA to some initially, helping them transition using a tool which is available on our website, which is called as Do Smart Analyzer, which allows us to analyze test cases, analyze user stories, analyze defects, using some of the ideas that I briefly talked about. Whereas Discover Smart QA, as I might have outlined some time ago, it is more of a month, it's an email-based, task-based program which is offered free. Whereas some of the other ones, which is Do Smart QA Individual, which is more like a coaching of the methodology called HyBIST, which I kind of do every once in 2 months or so. That is one. And of course, we extend that to organizational consulting, team consulting, and so on. And finally, of course, I also do approximately once in a quarter. Currently, there's a cohort 5 which is running, which is more of a higher order thinking skills coaching program where we discuss about 30 different topics over a span of about 16 weeks. Of course, what you see in the center is the commercial part, so to speak, because that consists of coaching for individuals, teams, and organizations, including consulting and advising. So, thank you so much.